Alright, we got another request for a couple problems. So we're in the second period now, and this will be the 5th video that I've created so far. So we're going to look at problem number 20. So in problem number 20, they want to know which compound has a greater percent by mass of chromium. And they give you two different ones. You've got K2CrO4, and then you've got K2Cr2O7. And they want to know which one has a greater percent chromium. Alright, so this deals with percent by mass. And percent by mass is always mole over Mach. And what that means is mass of the element over the mass of the compound. So we have quite a bit of math to do on figuring out the molar mass. So potassium has a molar mass of 39.1 grams. Looks like there's two of them. Chromium. The element chromium has a mass of 52.0 grams per mole. And there's only one of them. And then oxygen has a molar mass of 16.0 grams, but it looks like you've got 4 of those. Okay, so for this first one, you want to put the mass of chromium up on the top. And there's only one chromium in the formula, so we would put 52.0 grams on the top. But the bottom has to be the mass of the entire thing. Alright, I got a total mass of 194.2 grams. And you'll just times that by 100 and we'll figure out what percent that one is. For this other one, kind of the same process. This time the chromium, if you look at the formula here, looks like you've actually got 2 in the formula. And then oxygen, now you have 7. So for this guy, you're going to want to double up your chromium. That'll give you 104.0 grams on the top this time. And then the total molar mass, let's get that. Okay, I got 294.2 grams on the bottom here. Alright, so let's compare. Up top, I got 26 point, if you want to round, 8%. And for the bottom, I got 35 point, if you want to round, 4%. So the second compound has a higher percent of chromium in there. Alright, the next problem that they want to look at is problem number 21. Okay, for this problem, they are asking which gas will effuse faster, chlorine or argon, and then it asks how much faster. So the first thing you have to do is realize, first of all, this is an infusion problem, and let's compare these two gases. We've got chlorine versus argon. So the way that you determine which one is going to effuse faster is you have to look at their molar mass. So on chlorine, it's 35.5 grams each. You've got to double it because it is not a noble gas, so it does need to be doubled on the equation there. This guy is 71.0 grams per mole. But argon is a noble gas, so you only need one of them in the formula. His molar mass is 39.9 grams per mole. So the little guy always is going to go faster. Argon is going to be faster. Now, a lot of you guys are pretty confused when you get this formula. Hold on. Molar mass B over square root molar mass A. So a lot of you think that you need to use this particular formula for all effusion problems, but that's not necessarily the case. In this question, they just want to know which one is faster and by how much faster. So when you get these particular problems, they just want to know over here, what is the ratio between the rate? Like if I say, hey man, I'm twice as fast as you, what that means is that the value here is larger than 1. right? If I'm 2 times faster, it means the value 2 is larger than 1. So the way that I would set up this side over here is that I would always put the larger mass up on the top and the smaller mass down on the bottom. So in this particular question, you don't have to solve for, both the top and the bottom. That's not what we're doing. We just want to figure out kind of like a number that would represent how much faster one particular gas is. So we're looking for a value to be over here. So x is equal to the square root molar mass B over square root molar mass A. And then you're like, dude, which one's A, which one's B? Well, guys, we already know that argon is going to be faster. We're just trying to figure out how much faster. So if we're looking for one particular gas to be faster than the other, you're going to want to put, so that you get a value, this x value needs to be larger than 1. If we want it larger than 1, you just put the larger molar mass on the top. All right, so we're going to put the 71 on the top, and we're going to put that 39.9 down on the bottom. And I get a value of approximately 1.3. So what this means is that argon is about 1.3 times faster than chlorine. And that's how you would answer that problem. All right, I hope that was a little helpful.